Hey boys and girls, today we're going to be learning about how to divide decimals using 3 different strategies. We're going to look at estimating, using the area model, partial quotients, and using the standard algorithm. Alright guys, so we're going to start out here with using the area model. Now before I divide, I always want to use my estimation skills before I start dividing to know what I'm looking for. So right now I'm looking at 38 and 46 hundredths divided by 6. 38 and 46 hundredths is my dividend and 6 is my divisor. Well, 6 can't go evenly. It's not a very pretty number to go in evenly. So I know that 38 is close to 36. I know that 6 times 6 equals 36. So I can round and estimate that this problem will be similar to what I get when I divide 36 divided by 6, which equals 6. But now I'm going to use the area model to divide. When I use the area model to divide, I want to decompose my number into expanded form. So I'm going to split it up into wholes, tenths, and hundredths. I'm decomposing my dividend. My divisor is staying the same since I'm dividing right here. So I'm going to start with my wholes, my ones place, and I'm going to think to myself, okay, how many times does 6 go into 38? Well, I know that 6 times 6 is 36. If I was to take out any more groups of 6, say seven groups of 6, that'd be 42. That's too many. I don't have that much to take from to divide up. If I was to take out less than 6 groups of 6, I would have way too much left over, which would cause there to be multiple digits in one place value, which we know we're not allowed to have. So the perfect number to take out is 6 groups of 6, which equals 36 wholes. When I do go to subtract those, I do get a remainder of 2. I need to regroup those 2 over to my tenths place. So now in my tenths place, I want to divide out 2 and 4 tenths. I want to know how many groups of 6 are there in 2 and 4 tenths. Well, 2 and 4 tenths is less than 6. So I'm going to have to take out a small piece of a group of 6. Remember that when you take out a decimal, you're taking a part of that group. So I'm going to start doing some facts over here to the side. I know that 6 times 1/10, taking a tenth from that whole group of 6, I would be left with 6 tenths. Well, that's not quite enough. So looking at these digits, 2 and 4, I know that if I took 6 and multiplied it by 4, I would get 24. Well, those digits are the same, but my place values are not the same in those two numbers. So what if I was to multiply 6 by 4 tenths? Then I would get 2 and 4 tenths, which is exactly what I'm trying to take out. So when I'm taking out a group of 6, I'm taking out 4 tenths of a group. I'm taking a part of that divisor 6 out in this place value. Just so happens that when I do that, I'm left with 0 as a remainder. So when I move over to my hundredths place, I don't have to regroup. Now I'm looking at my hundredths place, and I want to know, okay, how many groups of 6 are there in 6 hundredths? Well, if I took 6 and multiplied it by 1, I know I'm going to get that ideal digit that I want, that's 6. But this 6 is not in the same place value as what I get when I multiply 6 times 1. I need there to be 2 digits after my decimal, so I can take out a hundredth of that divisor 6. It just so happens that when I do that, I'm taking out all that I have left, 6 hundredths, leaving me with no remainder. But it also doesn't really show me where my answer is. So my answer, believe it or not, is actually going to be located right up here at the top of all my place values. All of those pieces of groups of 6 that I took out from 38 and 46 hundredths. So in the end, my final quotient should be 6 and 41 hundredths. In the number 38 and 46 hundredths, there are 6 and 41 hundredths groups of 6. This is probably the most confusing way to divide decimals, but it is effective if you are very comfortable using place values. Dividing using partial quotients is a little bit easier, but still, in my opinion, not the best option. But let's go ahead and try it here. When we do partial quotients, we might also call it hangman. Some of us might show our math like this to divvy up where we're going to find our quotient versus where we're going to be subtracting and regrouping as we're taking out different groups of 6. So again, I'm looking at 38 and 46 hundredths, and I'm dividing that by 6. When I do that, I know that 6 times 6 is 36. So I'm going to start by taking out 6 whole groups of 6. When I do that, I'm left with 2 and 46 hundredths. Now, in my next step, I know I'm going to have to take out a part of the 6 because 2 and 46 hundredths is less than my divisor 6. So I know that this partial quotient right here is going to have to be some sort of decimal. So I might see that, okay, 6 times 4 tenths equals 2 and 4 tenths. Always put my placeholder whenever I'm subtracting. That leaves me with a remainder of 6 hundredths. Well, I know that I can take out a hundredth of my divisor 6, which is when I multiply 100th times 6 is 6 hundredths, leaving me with a remainder of 0. So I can find my quotient now over here on this side by adding up all my partial quotients. So I'm going to have 6 plus 4 tenths plus 1 hundredth. Don't forget that when you add, you have to line up your decimals. When I line up my decimals, I look like that. Always start adding in your smallest place value to get 6 and 41 hundredths, which is exactly what we got the last time that we did this problem using the area model. Another great thing about partial quotients is that you could have done this in a few different ways. So for example, I'm going to come back here to the very first step that I took. And instead of taking out a group of 4 tenths, I might say, okay, I didn't know that 6 times 4 was 24, but I know that 6 times 3 is 18. Therefore, 6 times 3 tenths is 1 and 8 tenths. Glad to put my placeholder. And then I'm going to subtract, borrow, and now I'm left with 66 hundredths. Well, I know that 6 times 11 is 66, but I need 2 digits after my decimal. Therefore, I'm going to place my decimal in front of the 11 to make 2 digits after my decimal. So now when I take out a group of 11 hundredths of the whole 6, I'm going to take out 66 hundredths and get that remainder of 0. My answer is still going to be over here on the side, adding up all my partial quotients. But this time when I line up my partial quotients, I'm going to have 3 tenths and 11 hundredths. I should still get 6 and 41 hundredths. So the beauty of partial quotients is that it doesn't have to be perfect. You don't have to take out a certain number of groups every time, and you could still get the problem correct. Now, in my opinion, the last way and best way to solve a division problem is using the standard algorithm. When you're using the standard algorithm, the problem that I see is that you don't know where to put the decimal in your quotient. Well, it's quite easy. You're going to move it up directly above where it goes in your dividend. The trick here is when we put our quotient up top on this line, you have to make sure you're putting it in the correct place value. So remember, when we do the standard algorithm, we think dad divide, mom multiply, sister subtract, brother bring down, and rover repeat or remainder. So when I do this, I'm going to start with dividing. I know that 6 cannot go into 3 because 3 is too small. So I'm going to put an X or a 0 up there in my quotient to show me there is nothing that can go in there. But I can move over and I can combine these place values now. And now I can think, how many groups of 6 are there in 38? Well, I know that there are perfectly 6 groups of 6 in 38, which equals 36. Sister is going to tell us to subtract, and I get 2. Now that my decimal is up where it belongs in my quotient, I get to forget it exists. So when brother tells me to bring down, I'm going to bring down this 4, and I'm going to act like now I just have the number 24. So I need to look at how many times does 6 go into the whole number 24. I know that 6 times 4 is 24. Therefore, it goes in 4 times. Sister tells me to subtract. I have a remainder of 0. Brother tells you to bring down. Now I'm looking again. I got to repeat and go back up and follow these steps again. How many times does 6 go into 6? Well, that's going to be once. 6 times 6 is 6. Subtract, my remainder is 0. And what do you know? I get that exact same quotient that I've gotten in my last 2 examples using 2 different strategies. This is my personal favorite strategy to use because it works for every problem and you can follow the exact same steps. But it's very important that you take out the exact correct amount in each place value. If I was to take out only 5 here, that would be 30, which causes my remainder to be 8. So now I've got a 6 divided by 84. Well, I need 2 place values in just that one place value. 2 digits in that one place value. And I can't have that. So it is very important that you take out just the right amount in each place value. Now that we've done this top part of this note sheet together, I want you to go ahead and take a crack at these bottom ones. So this is the same problem, but it's using all 3 of the different strategies that we used. You only have to solve it one way. If you want to solve it all 3, be my guest, but I want you to try to solve it, and I want you to pause the video right here before you go ahead and look back to see if you got it correct. I hope that your quotient was 7 22/100. If not, please take a second to pause this video and check your work with the answer key listed on the screen. I hope that you feel more comfortable with dividing decimals by a whole number now. We need to make sure that we get real comfortable with this before the end of the year.